Speaker hitting the stage is Raúl Sánchez. Raúl is a software developer from eProsima.
And Raúl is going to talk today about how to build robotics applications based on ROS2. And those applications are distributed along different computers in the edge and in the cloud. His talk is titled Distributed Robotics with ROS2 and Vulcanexus Cloud. Welcome to this conference, Raúl. Are you ready?
Yeah, hello.
Hello. So everything is ready?
Yeah.
Great. Then the audience is all yours. You can go.
Okay, perfect. So yeah, as Ricardo was saying, today we are going to learn how to create a distributed network of robots. So you will be able to learn how to create your robots on the edge, set up everything with ROS2. For this specific scenario, we will use simulation. And also we will be focusing on those distributed deployments, also distributing some ROS2 nodes on the cloud. So for this specific demonstrator or for this session, I will create the simulation on one side, then on the cloud or a reproducible cloud, I will create the controller, and you will be able to experience how this is done using Vulcanexus. So first of all, before going into any details, anything else, I want you to scroll here to the a little bit down on the notebook and open a terminal and run this command, because this will install everything you need for running this demo. So let's open here a new shell and just paste here this command. Okay, so there are a lot of things going on the background. Everything is trying to be installed, but once we have done this already, I will talk about a little bit about Vulcanexus. So Vulcanexus is all-in-one ROS2 toolset in which we gather ROS2, and also we provide you with a lot of tools, a lot of set of applications for you to monitorize your ROS2 network, to try to debug your ROS2 deployments. And also there are some specific tools for this kind of distributed scenario. So for example, if you go here to the Vulcanexus website, you will be able to see that on the core. So here on the products, you have the core, which is ROS2 and comes with FastDTS middleware by default, and this is the only one. Also, it comes with Secure ROS2, but also you can access a lot of tools here within Vulcanexus, like for example, the ROS2 monitor that I've already presented in the past ROSCon in Japan. Also, you have Vulcanexus Cloud, which is the one that we are going to use here for this specific demo, which comes with the ROS2 router, which allows us to connect the edge deployment to the cloud deployment. Then we have some simulation, the simulation package, which comes with Weebots, and then the distribution for micro, which uses micro ROS and puts ROS2 into microcontroller. So this is Vulcanexus. Vulcanexus is the distribution that we are providing you from eProsima with the latest version of FastDTS. So one of the most important things here is that it comes with the latest changes of FastDTS. So for example, let's say that we develop a new feature of security, a new feature on the DDS router for distributed deployment. For example, the last feature that we added to the ROS2 router is providing security, how to secure your communications across different machines with Vulcanexus and the DDS router. This is already done as a new feature on the DDS router, and this will come with the next release of Vulcanexus Cloud. So at the end, it's ROS2, but with a lot of things that we provide on top of that in order for you to be able to deploy your ROS2 network easily and without any issues. And also for the simulated environment, I will use the ROSBot XL robot from Usarion. You can check here in the link the documentation from this robot. Everything will be simulated for this. for this demo, but you can check here the specification of the robot. It's a 4x4 drive autonomous mobile robot which comes with LiDAR, cameras, IMU encoders, and also it's coming with a Raspberry Pi, so you can configure everything within the robot. So yeah, it's perfect for you to start testing and play around with ROS2 and an actual physical robot. So once I have this introduction, I think that I've skipped my presentation for a moment, but yeah, I'm Raúl Sánchez-Mateos. I'm a senior software engineer and project manager here at eProsima, which is the company behind FastDS. I think you already know that. Some of you that have already fighting against ROS2 and this middleware, but yeah, we are behind FastDS, and with Vulcanexus, as I said before, we'll try to provide as soon as possible the latest fixes and the latest bug fixes within FastDS without for you to worry of this kind of versioning. So yeah, I've seen that we have Vulcanexus already installed. Also, there are some dependencies that I have previously installed within this bash file here that I needed for the demo. In case you want to check what I've been doing on the background here on this Vulcanexus installation script, after this is loading, I can show you the script, and yeah, here you have on the eProsima. It's on, I think it's on utils, Vulcanexus install. So yeah, it's a bunch of commands just for installing Vulcanexus and some other dependencies. That's all, nothing more. So yeah, we have installed Vulcanexus, and how to source Vulcanexus is just as simple as sourcing ROS2. Just call this command and you have it up and running. Now I'm going to go into more detail on the scenario. So for this kind of deployments here on the ROSjet, we don't have the possibility to create an actual physical distributed deployment with a lot of computers, a lot of different locations. So what we have done here in order to isolate the simulation from the cloud deployment is to use the ROS2, the ROS domain IDs. So every time that you have a new domain ID, you have everything within that domain physically isolated because they use internally different ports. So you have here the simulation running on ROS domain ID 0, also one DDS router running here on the edge, then another ROS domain ID number 1 with Rviz and also the manual controller. And also here you have another DDS router. So the communication is going to the simulation here. The simulation will be running, then everything will go through this DDS router communicating to the other DDS router. Let's say that everything is isolated and separated, but not those DDS router, which will be able to communicate. Everything will go through that. And the second DDS router will get all the data, put it into our Rviz application. And here from the manual controller, we'll be able to send commands to the simulation, and the simulation will report back to the Rviz the current execution. So this is how this demo is going to work. So I will let you know, I will say now how we are going to deploy all those kind of things. So let's say that this image will serve us as a index for the whole presentation. So keep that in mind. And let's going through the first step of the deployment, which is running the simulation. So the first thing to do here is to run the simulation. Here we are going to use Gazebo because there have been some issues with the latest release of Weebots for now, but everything is already fixed. So in case for the simulation you want to use Weebots, it's already installed in this ROSjet, but as it is actually on the ROSjet, for now we are going to use Gazebo for the simulation. But if you want to change, I provide you here at the very bottom of this file how to run everything with Weebots. So yeah, let's stop talking about introduction and all those kind of things, and let's move on to the simulation. So just copy those those commands, and let's use this terminal to run the simulation. So here we rename it to simulation, and we have it there. We source first Volcanexus, then we have to source the simulation environment that we have previously installed for the ROSBot Excel simulation. Everything as usual. So everything is already installed. You don't have to do anything about the installing anything else for the simulation. In case you want to know how I've been doing everything, all the steps that I've been following to install all those kind of things, you can go to your workspace here. If you go to utils, then you will be able to see here the commands. It's on Usarium, Gazebo, ROS. Yeah, those are the commands that I've been using to run, to install everything needed for running the simulation. The same for Weebots. You have all the commands here in case you want to reproduce them locally and try to create your own workspace. And for the steps on how to deploy everything with Weebots, as for Gazebo already have it on the notebook, but for Weebots, you can check here all the commands and everything step by step, how to run the latest version of Weebots, which is the a beta version of 2023B, and with all the assets, everything that you need. So you have everything on the utils. If you don't know how I've been doing anything to prepare the ROSBot, you have everything here. So just go to the utils folder and you can follow the steps, and that's all. You will be able to reproduce the exact same scenario that I have here. So yeah, let's run the simulation. We are running ROSBot Excel Gazebo simulation launch spy, and this in a moment will open Gazebo. So yeah, everything should be up and running. Okay. Okay, so here we have our simulation, and if you check here, here is the Usarium robot, the ROSBot Excel. Okay, so now we are done with the edge for now. We are going to move on with the cloud deployment and how to run Rviz. So as you already know, Rviz is for commanding and also gathering information from the simulation, or also the actual robot in case you have it. But for now, we are been working with the simulation, and let's go directly to run Rviz. I've provided you with the configuration file for Rviz, so you don't have to do anything else. Just run it, and that's all. One important thing to mention here is that if you check the command here, I'm first of all, of course, sourcing the Vulcanexus workspace, but also I'm running Rviz on ROS domain ID number 1. That way, we have the simulation on one domain, the Rviz on the other domain, and everything will be completely isolated. They won't be able to talk to each other, and they won't match. So copy those commands, open a new tab on the terminal that we have already open here, rename that terminal to keep track of everything that we have been doing, and I will call it Rviz here, and paste the commands. As I said before, here you have the display config file, which is on this folder, on the eProsima workspace folder. You run it, and Rviz will automatically open. So if you check here, nothing is printed. That's because they are on different domains. They won't be able to communicate. So for now, you won't be able to see anything, and that means that everything is working properly. So don't panic yet. Okay, one thing to comment here for all of you is that we have seen that I will talk about a little bit more about the DDS router, how everything is configured. But for you right now, for you to know, you have to go to the laser scan here topic in order for you to see the scan topic for coming from the simulation, and change the reliability policy here to best effort. Okay, that's everything that you need to know on Rviz to have everything working in case you have it configured as reliable. So once you have done so, we can move on with the next steps. Okay, here we have Rviz, nothing is communicating. So yeah, we are on track. Okay, so once we have done, we are finished with the simulation, we are finished with Rviz. Now we are moving on with the cloud controller. So the cloud controller is a very basic teleop twist keyboard application. So it's just an application to send commands to through the keyboard to the simulation in order to see that everything is running, but it will work exactly the same with some other frameworks. Like, for example, if you're running navigation on the robot and on Rviz, then you will be able to use navigation topics. That doesn't matter. I mean, the DDS router at the end didn't know which topics are you running. It will just gather all the data and moving that data to the next DDS router, and that's everything that you need to worry about. We'll see later on how the DDS router is configured. It's pretty simple, but yeah, as I said, this is pretty simple. The manual control is simple for you to just to check how everything is working and how everything is being deployed. But if you want to use this in your actual deployment with navigation, SLAM, and some other toolkits, the DDS router will be working as it is on this demo, because DDS router have support for ROS2 actions, ROS2 services, of course, ROS2 topics. So everything is supported. And yeah, we have, let's run the manual controller on the ROS domain ID #1, also the same as we did with Rviz. Let's copy all those commands here, move it to a new tab on this terminal, rename it as before, cloud control. Okay, so we are keeping track of everything that we have been doing. Paste the command here and run it. Okay, so now we have the teleop, teleop application running, and let's say that we want to move our robot. Everything is on different domains. So if I enter here some commands, so it's okay. I don't know why it's not getting any command here. Okay. Let me check again.
Yeah, now you have the focus.
Yeah, I mean, I have the focus, but it's not getting anything from the keyboard. I don't know why.
Raúl, maybe it's the simulation that the controller, for whatever the reason, the first time that you launch it, didn't load. You know the controller? Maybe relaunching it?
Yeah, I've already done that.
Oh, okay.
Yeah, I've stopped it. Run it again.
No, yeah, I mean relaunching the simulation.
No. I mean, I don't want the simulation to work with that.
Okay.
I just wanted to show you that if I'm pressing any keys here on the control, nothing will be moved to the simulation.
You're in the different domain.
That's
true. Sorry. I interrupted.
So yeah, I mean, if nothing moves on the simulation, means that it's actually working.
Yeah. So, that's right. Sorry, I forgot.
So,
sorry.
The thing here is that if when I was pressing here some commands, usually it appears here the command that I've been pressing. So if I press I, for example, then it should appear here, but I don't know why. yeah, it's moving. I don't know. And nothing it's printed here on the cloud control. I don't know. I don't know why. So yeah, let's keep with the with the hands-on on the distributed architecture, and we can move back to the cloud control later on. But okay, so yeah, nothing should move. That's the thing right now, because nothing is connected. So the first thing to connect everything is to deploy the DDS routers. So let's start with the DDS router on the edge, which will be the one connecting domain 0 and the second DDS router. Here you have the configuration file for DDS for this edge DDS router, and if we check here, this is the it's not the most simple configuration for the DDS router, but it's a pretty simple configuration. So the things that you have to set up here in order to configure your ROS2 or DDS routers are to first set up the version that you are using. The latest one is 3.1 with this new secure communication that I've been talking about, which will be released in the next version of Vulcanexus. But for now, we have to stick to the 3.0 version. Then we have to configure the participants, the actual participants that will be deployed inside the EDS router. Those are the same as the ROS2 nodes. And here we have to define two different participants. Okay, so here we it says server. This is actually edge. Okay, and yeah, we have the first participant is a simple participant in domain 0. So we will connect to ROS domain ID 0, and then we have the other participant on the one on the internet on the one edge, which will communicate to the other DDS router. So the edge DDS router will act as a client, the second DDS router will act as a server, but you don't need to define all those kind of things. Those will be automatically set up on the internal configuration of the DDS router. The only thing that you need to set up here is to define the kind of the DDS router that you're using, which is one DDS router for communicating through the internet. Then you set up the connection address. Where are you going to communicate? Just keep in mind that everything that we're running is on the same machine. So we are saying here that we want to communicate to the IP or domain DNS localhost and to this specific port, which is the listening port on the other DDS router. And then we have also here the listening addresses to specify from which addresses will be receiving data. And the same as before, DDS router will be working with DNS. So you can specify here localhost. If you have your own server with DNS defined, with a domain name defined, you can use that. But yeah, you can define localhost here, the listening port, and the transport protocol that you're going to use, which in this case, as everything is running locally, we are going to use UDP, but you can use TCP in case you want a higher deployment over the internet. And if you configure TCP, you will be able to configure TLS, for example, for secure communications, and SNI for TLS in case you want to define a specific domain for your several applications. So all those kind of things can be configured using this kind of participant on the DDS router. But for now, we'll keep it simple and have this kind of configuration. So let's run the first DDS router. Same as before, source Vulcanexus, everything is already installed. And here we have the command for running DDS router. So we will open a new tab on the same terminal here. This is the router edge. Okay. It's here the commands, source Vulcanexus, then run DDS router with this configuration file, which is already saved here on the eProsima workspace, in case you want to check and modify that. And you have the first DDS router up and running, but nothing will work because we still have missing one piece of the of the deployment, which is the second DDS router. Once we have the second piece deployed, everything will be connected and everything will be will communicate. I hope so. So yeah, continuing with the second DDS router, same as before, version 3.0. Define our participants. Here, the simple participant, it's communicating through to the domain ID, ROS domain ID number 1, which is the one I have Rviz and also the cloud controller. And then we have the participant for the one server. And the kind is the same as before, but here, as this is our server, the only thing that we need to set up here is the listening address. Where are we going to, yeah, from where everyone on the edge will be able to reach us, okay? So we define our listening addresses here, the domain is localhost, then we have the port, and then we have the transport configuration, which is UDP. Okay, so yeah, nothing much to say about this configuration. I will move on later on a little bit of introduction on how to configure some other things for DDS router, but for now, let's keep it simple. And yeah, same as before, source Vulcanexus, launch the second DDS router with the DDS router cloud YAML file, which is the configuration file. So open a new terminal here, then rename it to router cloud to keep track of it. And yeah, paste it here. We have it running. And if everything works fine, yeah, here we have on Rviz our robot. So before, as you remember, we didn't saw anything. So now everything, all the communication, remember that all the communication is going through from here, from the simulation to the routers, coming to Rviz, and then from the manual controller, we are sending commands here to the simulation, and the movement of the robot, the feedback will move back to the Rviz. So here's the perfect deployment for cloud architecture, in which you have the monitorization system deployed on the cloud for anything that you have running on the edge, and you can send commands from anywhere, from any other edge, from any other cloud, and yeah, this is the example for cloud deployments. And also you can deploy as many edge nodes as you want, as the DDS router will get every data on one domain and put it to the other DDS router. So we can have here as many robots as we want. All the data will go in through the DDS router, and there won't be any issue on that. Okay. So okay, yeah. Let's continue here. Yeah, okay. I don't know if I'm going too fast with this. I cannot read while I'm presenting, so I hope that all the people is following me through this deployment. If not, Ricardo, just ping me and
Yes,
I can go
that's
back
right.
on.
You're doing great. Just to let you know that there's 10 minutes to finish.
Okay, perfect. Yeah, I have time enough.
Okay, great.
Okay, perfect. So let's come back to the cloud control to see if the gazebo can run it. So let's Control C here, run it again, and yeah, I mean the commands are not printed anymore in the cloud control controller, but we can see here that the actual robot is moving. So we can see it moving on gazebo simulation, and if we check here on Rviz, also we can see the movement here. If we press some keys, let me check. Yeah, so if we press some keys, the robot here, we can see the robot also moving on Rviz. So we are sending commands to the edge is reporting back to the cloud, and the cloud is printing the movement of the robot. So that's everything about the cloud deployment. Now I will change the topics, and I will I will show you how to debug all those kind of things in case you have any issues, any problems. We have developed a new tool called DDS Record and Replay, which let you record and replay some commands. So for example, let's say that you have your robot deployed on the edge, and you want to record every command on from the robot on the cloud. You can run the DDS record and replay on the cloud. It will record every command, and you will be able to replay these afterwards. One of the main thing here on this DDS record and replay is that we provide you with a remote controller system in which, let's check it here. You have you have here how it looks like, but everything internally it's built on DDS topic or ROS2 topic. So you can build your own controller for the DDS recorder on your applications. But in case you don't want to, we provide you with this kind of tool. So for I will let you know. I will show you how this works later on. But for now, we will continue with the DDS record and replay on how to debug your architecture. So this is the configuration file for the DDS record and replay. So one of the main things here is the DDS domain or ROS2 domain in which we are going to work on. Then we can specify a filter list just for getting the commands from command belt. So here we are going to just register all the commands sending from the cloud controller. Then we have the specific configuration for the recorder. So we can configure the file name of our system as always. And there are some things here that are very important for performance issues on other alternatives that we have been seeing. Here is that we can specify a downsampling mechanism, so we can keep one sample out of 10, for example. Also, we can specify the buffer size, internal buffer size, so we can set here how many samples are we actually storing on the process memory instead of putting in on the file. So for this example, we are storing 5 samples on internal process memory, and then after the 6th sample reaches, we are moving those 5 samples to the file and write on the disk. So here we can improve the performance of this application. And also we have this event window here, which it's very important. We, as I said before, we have the remote controller mechanisms for the DDS recorder. And let's say that you don't want to record everything on the network. You just want to record whenever something happens. So let's say that you have a temperature sensor and you want to record every time that the temperature reaches 40 degrees, for example, and you want to know why this temperature has reached 40 degrees, but you don't want to know everything that has been happening. So you have this kind of event window in which you can specify the remote controller to say, okay, every time that I get an event, so the temperature reaches 40 degrees, I want all the samples from 5 or in this case 10 seconds previous to the event. So I will record all the samples from 10 seconds previous to the event to the mcap file, which is the file we are using for saving data. And after that, I want to keep on pause state. I don't want to record anything else, or I just want to start recording everything after this event happens. So you can specify those kind of things using the remote controller. So I will run everything very quickly just for you to see how this works, and I can close the session. So just for running the DDS recorder, same as before. Right now, we don't have it on Vulcanexus. We have to install it manually on the eProsima workspace, but it will be on Vulcanexus on the next release, which I think it's next week or in 2 weeks. So we have the recorder here. We are going to run it. Now we have here our recorder tool on the background running. And we are going to run the controller. Okay, so here we have our controller. And if you go a little bit down here, you have the commands on how to run this remote controller system. And yeah, here we have it on the graphical interface. So this is saying us that the recorder that we have on the background is up and running. So let's say that we don't want to record all the things, so we can pause it. So after pause, we are not saving anything to the MCAP file, to the database. And I said that I want to run a new event. So I want to record every past samples of the past 10 seconds, and after that, continue recorder. So we send an event, and we start recording again. Also, we can stop the execution. In a stop state, you won't be able to record anything, but in case you want to start again, just click start, and everything will be again up and running. This is very useful in case you want to just run your recorder on the background indefinitely, and just keeping the controller here for communicating to the recorder. You don't have to act anything. You don't have to command anything to the recorder. Everything will be used by the controller. So I don't know if I have. I think we can close it here. There are a lot of things that you can do with that. For example, right now on the recorder, you will be able to record all the. If I go here to the cloud control, everything that I command here, everything that I write here will be recorded on the recorder, and after that you can use the replay mechanism to replay all the commands from the cloud and recreate the same behavior on the simulation. Okay, so yeah, I think there's nothing much to for me to show you. There's a video here that you can check. This is the actual deployment, but for this case, we are using another robot from Musarion, the ROSBot 2R. And yeah, this is the actual deployment with a physical robot, Rviz running on the cloud, running to DDS router. And in case you want to check on this, just click on the video and you can see an actual deployment, not a simulated one.
Okay, excellent. Yeah, so please, okay, can you tell us also about running this thing with Webot simulator? So you have included also there the instructions, right?
Yeah, here you have on the annex how to run everything with Webots. So if you want to give it a try, which I recommend you because Webots has a very cool interface. Also, they are about to release the new version, which is in beta state. That's why we couldn't go through for the Webot simulation, because we wanted to go with the latest changes of Webots, and we kind of didn't manage to solve some other issues because this is at the end a beta version. But in case you want to give it a try, I put it here all the comments that you need for running it, and it will work.
Okay, excellent. Well, thank you very much, Raúl, for your excellent presentation.
Thank you.
Thank you, Raúl. Okay, so now let's have some questions. So attendants, please go to the section Q&A tab and post your question there. So we're going to pick the most voted question to ask the speaker.
Yes, and then Raúl, we already have some questions for you. They are ready here, so the people have started. And then we have one that says, from Alberto, that says, what's the difference between this DDS recorder and a regular ROS2 back generated file?
Yeah, The ROSback, I mean, at the end, those application does the same. They record and replay, but we were focusing on some of the issues that the ROSback was having lately, on a huge deployment in which you run the ROSback and you want to record every topic. We had some users that they say that the ROSback freezes, they were not, or the ROSback was not performant enough to record this kind of deployment. So our goal here was to focus on the performance issues and try to address those kind of issues. So for example, on the DDS recorder, you will be able to configure things as the number of threads that you want to run on the background. So for example, if you have a high computational CPU, you can run a lot of threads. Then you can define also the memory usage, defining how much your internal buffer storage will be. There are a lot of things there, more focus on the performance. And as this is a completely new application that we designed from scratch, we focus on the performance issues and on the performance design that keep addressing that we can accomplish all those kind of things. And also, for example, the remote controller, the controlling mechanism, the event window that I explained before. Yeah, all those kind of things that we have added to the DDS recorder and replace to give it more valuable.
Yeah, which are not on the ROSback system. To be yeah. Okay, great. We have another question here, also highly voted, from Kaloyan, that says, is there any compression with the communication, or is it a one-to-one translation of the data sent and received?
Is there any compression with the communication? What do you mean? I don't know what he means with the compression. I mean, I don't know if he refers to DDS router, I think.
Yeah, I think he means that. Yeah, I think.
Yeah. So on the DDS router, let's say that you have a lot of writers on one side, I mean, a lot of publications on the simulation, and then you have a DDS router. So the DDS router will create just one single publication to gather all the messages coming from that topic and forward it to the other network. So at the end, the data, it will be, the number of packages will be reduced, because in FastDDS you will be able to gather a lot of samples and put it, all of them, into a single packet. So the number of the traffic going through the network will be reduced.
Okay, and
so yeah, it's a little bit tricky how to explain the internals of RTPS and DDS protocol, but at the end you will have a reduction of bandwidth about what the things going into the DDS router and the things that go out.
Okay, clear. And then another question very interesting, from Marcos Barrera, that says, can Vulcanexus be bandwidth constrained for certain topics over Iridium modems, for example, or other topics over low Earth satellites?
Yes. Yes, you can configure all those kind of things. I will put you a link to the documentation about FastDDS, how to do so. And there are some things on FastDDS, the internal middleware of ROS2, called flow controllers. So you will be able to specify a flow controller mechanism for one of those one of your topics, or a lot of them. And in this flow controller, you will be able to set up the priority of your topics. So for example, let's say that you have 3 topics. You can set up which one of those have a bigger priority over any other. And also you will be able to specify the bandwidth usage for this specific topic. You will be able to set up a specific bandwidth used on ROS2 or used on FastDDS just for this topic. It's called high priority with reservation flow controller, in which you set the priority of your topic, and then also you set up the bandwidth usage reserved for that specific topic.
Okay.
So yeah, you can do that.
Yes. Okay, then one final question, okay, from Volker Kohn. And he says, in terms of security, is there some, or can there be added some VPN to the Vulcanexus connection?
Yeah, I mean, we have been, by default, we are not providing any VPN provider or any VPN mechanism. I recommend you to take a look at the Usernet VPN, which is the one provided by Usarion, one of the partners that we have in Vulcanexus. So check out the Usernet VPN for those kind of things. But also we have been testing DDS router on Usernet, using also Usernet VPNs, and everything works out of the box. The only thing that we have to manage is to work with IPv6 addresses, which now the DDS router supports them, because everything on Usernet is going through IPv6. And yeah, you can use DDS routers with VPN applications, IPv6, and also UDP communication in case you are on the VPN. So
okay. Okay, then Raúl, we have to stop here.
Okay.
We can be here the whole day with the audience. So thank you very much for your presentation, Raúl, and your questions. Thank you.
Thank you.
Thank you, Raúl. Thank you. Okay, attendee, remember to read this presentation. You now will see a box in the chat room. Please read for this excellent speech by Raúl. So let's continue. I think so far we've already learned so many interesting topics.
Yes.
And I think we need to decompress a little bit. So right now, let's do a 20 minutes coffee break and do some relax and also observe the beautiful clouds in this city. And yeah, the robots. Okay, and the next speaker's section will be right back after this coffee break.
Yes, but today, this year, we have a novelty in this conference. So we want you to have this coffee break, but for some people that doesn't want to be waiting that long and they want something more to engage, we have prepared another contest where you can win some prizes. So what we have prepared, this is special, okay, is the following real lab, which is we call the Cyber Wall. It's a remote real lab that we are going to be streaming in a minute in real time. So you will see the construct Cyber Wall lab, which contains a ROSBot XL robot by Usarion, and then is included inside a maze. Then the goal is the following. You have to make the robot go from the start to the end point by sending commands into the chat. You see the chat here? No, there. Sorry. Yeah. So in the chat, you can send commands in order to move the robot in the proper directions. We have just a very restricted set of commands. It's left, right, forward, backwards, rotate left, rotate right. And then those commands, they have to be in capital letters, okay? So you can start sending commands once we start with the streaming, and then you have to try to make the robot reach the end point of this maze. If you achieve to bring the robot to the end, you will win 1 month subscription to the construct. But the trick is that all the commands that you type there will start moving the robot. Then you have to kind of collaborate if you want to reach the point. So for all the people that participate in bringing the robot to the end, if the robot reaches the end, all the participants will get this monthly subscription. Okay, so you have some work to do in case that you don't want to be spent drinking coffee, which who doesn't?
I already saw someone is typing the command.
The command,
in the chat room.
Okay, you say you hold your breaks there because we are still not streaming the real one. So now we are going to conclude here. So you took note of the commands, right? Left, right, forward, backwards, rotate left, rotate underscore left, rotate underscore right. Those are the ones in capital letters, and let's see what happens at the end of the coffee break.
Good luck.